Today we are going to talk about indigenous irrigation systems at different levels and different types. And to start with, we must understand the problem of water resource today in Sri Lanka. You can see that we have 103 river basins, and all river basins are receiving water from rainfall, and part of that can be absorbed into soil, part of that can be absorbed into canopy. Rest of the things, if there are no any absorption points, it will go to sea. But there are absorption points like reservoirs, major reservoirs, medium tanks, small tanks, and some other tanks which are really in the wild. So that there are opportunities for rainwater absorption in these river basins. Unfortunately, if you analyze the discharge to sea, it's about more than 50% of the annual incidence, annual rainfall. And because of that, sometimes you get drought, sometimes you get flood. In addition to that, in some places like Mena and Jaffna, there is a risk of seawater intrusion. That means the flow is the other way. We say discharge to sea, but sea can also provide water, brackish water, to the land. And also, when we look at this modern practices, planning, some institutes, some organizations, they have ignored the value of ancient water resources management. And also, when we say tanks and tank cascade systems, it doesn't mean that we have to rehabilitate these physical structures only. It is very much important to restore the ecosystems. But very less attention was paid on restoration of tank cascade ecosystems. And also lack of effective coordination among water-related agencies. You know, there are over 40 agencies dealing with water in one way or the other. That is, you can see that there's a good chance, opportunity, but still there's a lot of complicated situation has come up because of more and more agencies. They have their own objectives, you know. Because of that, they will compete the water resource. And sometime, for example, if you look at this irrigation ministry and, irrigation department, then you have another water supply and drainage division, then Department of Agrarian Development, Department of Agriculture. All these agencies need water. The problem is how they can share it. For that, we need a particular group of people to manage, discuss, plan, and manage each and every year how we can utilize this water resource. The other one is, unfortunately, although we are proud of being having a water civilization in Sri Lanka, we don't have a national water policy. Recently, in January 2021, a team appointed by the cabinet, They have prepared the national water policy, but still it is there. No one has followed it up. On top of all, now we are facing another very acute problem, climate change. You know, climate change vulnerability is in a very high rank in Sri Lanka. The climate change affects directly and indirectly agricultural productivity. Sometimes it will lead to cause natural disasters like floods and drought, increasing the spread of communicable diseases, so that floods and droughts both will affect agricultural productivity. We have, as I told you, we have 103 river basins, major reservoirs and dams about 80, small tanks now, according to our new records, it's about 15,000, and small anecots about 13,000. If you look at this annual average rainfall, somewhere around 1,900 something, we say 2,000 millimeter. Land extent is 65,610 square kilometer, including water spread areas. If you take this very simple calculation, you will come up with the value, total volume of water, 131.22 billion cubic meters per year. Unfortunately, discharge to sea is about 66.18 billion cubic meters annually. That means almost more than 50%. More than 50% goes to sea, so that our water management is not working properly. One of the reasons for this one, if you look at these well-known rivers, the Duruwe, Kalawe, Mallatwe, Yangwe, those are in special dry zone. Kalniganga, Ginganga, Kaluganga, those are in wet zone. Walave Ganga, Mahaveli Ganga, Miyoe, etc. If you look at this total basin area, it is not much different, except Mahaveli and Ginganga. River lengths are there. Total rainfall, million cubic meters are there. And drainage to sea is like this. And finally, we find percentage of this volume wasted into sea. If you look at carefully here, you get very low amount, 13%, here 12%, here 19%, and here 16%. Those are less than 20. If you look at this Kalaniganga, Ginganga, Kaluganga, you know this, you have heard very recently, there's a risk of flooding the lower part of these drainage basins, right? So we can see that in dry zone rivers, frequently we get drought. In these wet zone areas, frequently we get flood. So there is an imbalance. Now, for example, here Mallathuye, we get only 12%. Why? It has small tanks 1,731 and also major tanks 5. Just to compare, okay? If you are interested, you can go to the internet and find all these details in different river basins. Now, if you look at another river basin like Gingaga, you get 62%. No major tanks, no small tanks. So no absorption point. right? So what we have to do, we have to increase absorption points. We have to increase diversion canals to any other drainage basins. That is what really ancient people did. They have done a very good job. Water resources management. When you say water resources management, it's not only for irrigation. Yes, irrigation for food production, that is the starting point of water management, starting from Mana. You may come across one natural harbor, Alirani Harbor, where you get a lot of sailors coming into that and they pay tax. And finally, they wanted food. So that our people wanted to have some kind of paddy tracts. And they wanted to build up a big reservoir called Yodawawa and also 162 small tanks below to feed them, right? That is the starting point of our irrigation technology. And also, as you know, that human needs for settlement, for drinking water, for bathing, recreation, other domestic needs, they need water. So our ancestors, they planned not only for irrigation, for human needs. And also they practice rainwater harvesting systems. Nowadays, we are talking about rainwater harvesting as some kind of practices came from other countries. No, it has been here. Then to ensure the existence of the environment, especially flora, fauna, and other part of the environs. And also, you know that in Anuradhapura and Sigiriya, they have used water for cities, city planning. They have ponds, they have even water springs, and so on. And also parks, landscaping, etc. Water springs, ponds. If you go to Sigiriya, you will observe that water springs are still there. Then there's another one. In the history, we found that there are administrative boundaries based on river basins. At the same time, as people are experiencing natural disasters like flood, drought, cyclone, and diseases, epidemics, they need to mitigate that, otherwise they cannot live. So that they wanted to use water to control these natural disasters. You see here, this is Sigiriya, this is Pidurangala. They have a lot of relationships there in these rocks, and we will discuss about that. And also, you can see the indigenous technology with very advanced engineering designs. You see, this is from Isurumuni. Sorry, this is from Ranwasuya, close to Isurum. If you look at indigenous irrigation systems, we believe that there is a master plan starting from river basin levels, from river to river, from reservoir to reservoir, and on sub-watershed level, village level, and field level. So that you can see this strata will indicate you that how the plan is so much of advance in these days. We will try to touch some of these things. In Sri Lanka, in the history, we heard that there were 10 kingdoms. Kevesastapa, northern part, Kavastalaba, starting from Yangway, Rakungiri originating from Mallatway, Upulangiri. Rakungiri means Ritical, Upulangiri means Nabulla. Then Indra covering Maduroe, Mundaniyaru, Galloe. Then Agni covering Kumbukangwe, Manigang, Kirindioe. If you just count all these, it will be 16. Those 16 rivers, we generally accept the fact that these are the major rivers covering our island, right? So that they have some kind of governance. The local king was on the top of this, on a ridge or on a crest or on a mountain, right? So this is the fact that we have basin level water governance. It dates back to 3000 before Christ. Then here, inter-river basin, from one basin to the other one. For example, here, Kalave Basin, it will go to Mallatway. It will go to Mallatway. Then from Mallatway to Kanadarawe. Kanadarawe will join again to Mallatway. So Dambuluwe Mallatway diversion canal, that is here. You can't see now. There are remnants. You just walk this and find it. That was built up in 860 AD. Same time, Mallatway Kanadarawe. You can see that even though those are the upper parts of these rivers, they know that the water here is so much rich in water, so that they wanted to have some diversion like this. So, rich river basin with plenty of water will provide poor river basins with less amount of water. So that is the plan. That is the inter-river basin level planning. If you look at this Yodala, I will show you again here. This is Yodala. Yodala has one diversion here to Nachad. Okay, I will go to the other one. You can see here one diversion to Nachadu. And if you look at that, this is a very, very particular one, very unique one, very specific to Sri Lanka. If you look at this Yodala from Kalaweva to Tisaweva, it's a zigzag, very abnormal way of running that one. They could have had it straight like this, but they didn't. The problem is now, one is that it can collect water from the upper part. It is single bank canal, so that the bank is lower part. It runs alone, almost contour. You can see contours. Water is collected from upstream. This is Manava Cascade. You can find it can collect water from some cascades, and also it can provide water to upper part, upper Mahakanumula Cascade. So both way it can operate. And also it can provide water both sides, this way or the other way around. And also if you look at very carefully here, all these tanks, right? Tanks it meets anywhere, will go around that one at the high elevation, so that the tanks are safe. Tanks are getting water, not sediment. So that it's another way of showing the wisdom of this water civilization. So what happened in 1970s? Now this is the contour. So it always followed contour. What happened in 1970s? They wanted to straighten up this. And to me, it's a disaster. And also, it's a massacre because they have not understood the real importance of this Yodala, and they have modified it. And now we are losing everything, all these essence from this Yodala. So I consider that as a massacre. Now this massacre is there. There are some people who are responsible for this. One of the person is one of my friends, engineer Mahinda Panapitiya, who wanted to confess this. He said, and the inconvenient truth behind engineering designs of irrigation projects developed during the last century. Those days we thought that the canal was planned to avoid rock barriers. That is why it runs in a zigzag manner. As the ancient people did not own the technology to break them. So that's a funny thing because if you go to our history, we will see that they are using rocks to do everything, everything. But these people, these engineers, they believed that our ancient people didn't know how to tackle the rock. So if you're interested, you can go to Economic Review in 2010, Indigenous Agriculture Knowledge in Sri Lanka. You can read a lot. April, May 2010. That is even in the internet, I think, yes. There's another very advanced technology. You see, this is the Yodala, right? It runs along contours, almost. But at the same time, in some places, like if you get a drainage here, so water in the upstream will come and get stored here. And they have provided some space here. So their bank is here and water will come and get a kind of turbulence. At the same time, the water is coming from this upper part and it adds here, and so many sediments are there so that this turbulence will collect and store these sediments at the bottom of this particular one. This structure is called Diakaliya. It means that water turbulence pond. If you go to Mahaluppallama, you will find one Diakaliya, right? If you go to Amanukole, further down, you will find this Diakaliya. And the beauty of this, these are Diakali, right? And it has sluices here, upper sluices and lower sluices. These lower sluices will provide water to lower part of this, mostly sometime cascades. And also, these upper sluices will contribute water to the Yodala. Okay, so that it's always association is there with Diakaliya and tank. Diakaliya and a tank. So if you look at as an example, Cornwaver here, there's a Diakaliya here. Then Amnukole Waver, then there's a Diakaliya, then Aluttava and so on. So this is a technology they have developed to keep water as it is, just to address the problem of drought Even if you don't get water from Kalaweva, still you get some water here in Diakali and pass it over to the lower part of the land. And at the same time, it will come and get it collected here in these tanks. So tanks are filled with water. These ponds are filled with water so that if there is any kind of long drought, this will serve the purpose. That is why they wanted to have this Diakali. The differences are there. This is Diakali water balloon pond. This is Weber, the tank. Diakali is placed above the canal. Weber is placed below the canal. That is one difference. Another difference is canal has been connected to the Diakali directly, but when you see tank, the canal just flows above the Weber to arrest the sedimentation. Then Diakali has been connected to a natural rock line or soil ridge to control water flow. Bund of the Weber has been raised to a higher contour. Issue of water through a natural process. But here in Weber, the water is released through sluices. Sediment is controlled here. Here controlling the sediment and providing water to paddy tracking. Both are sediment traps. Providing water to upland cultivation combined with human settlement and cascade system. Those are the different things. Anyway, just try to understand slowly why they wanted to have Diakali, why they wanted to have tanks, and also tank cascades. Okay. Again, the other one is from Yodala to Nachadu Reservoir. From Yodala to Tisaveva, from Tisaveva to Basavakkulama, then it goes to Mahavilache far away, that is in the western part. Then here from Nachadu, there's another canal. Still, you can see that to Nuarveva. And finally, you can imagine a circle here which will get water from different drainage basins and fill in reservoirs. These reservoirs are feeding here water to the ancient city. So Kalaweva Tisava Yodala, Kalaweva Tisava Yodala, Nachadu Nora Yodala, Balalweva Simbalang Gamu Yodala, this is the one. Basavakkulam Mahavilache feeder canal, this is the one. So that they had the practice of constructing Yodala, the giant canals, because these are relatively large canals compared to the canals that they are using for paddy irrigation. Then not only this, they have a lot of anicuts, very big anicuts, try to divert water. Sometimes those are stone anicuts. They call Sukara Nijjar Ramuna. And also they have this timber. They have constructed the anicuts using timber. Kotta Badda Amuna by Kin Parakram Bahuwan. And also they have some rock blocks to construct this Amuna or anicut. Here also you can see that this is the natural one and it has been used with some kind of modifications as an anicut. Here you have another one. Here you can see still remnants. And one very famous, well-known Anicatis Tekkam Amuna. That is to divert water from Malatuya to reach Yodavava in Mana district. To fulfill the requirement of the capacity needs to feed water to 162 small tanks below. Because they need to produce foods, they need to feed the people who are coming from these harbors for trading purposes. If you go through my YouTube channel, you can see a lot of videos like this. And I just want to show you another one. This is the Sri Lankan map. And if you just locate or mark contour lines, this is the contour line and some elevations here. This 150-meter contour. If you draw that and if you superimpose that 150-meter contour, you will come up with the conclusion that a lot of ancient reservoirs like Kantale, Hurulweva, Minneri, Giritale, Parakram Samudra, in this side Kalava, Balalweva, Maduruva, Mapakadweva, Udavalva, so on. All these reservoirs are just hanging on this contour. You see how they could be able to plan it, what is the technology that they had those days. We don't know, we cannot understand. This is Anuradhapura district. Because of this network of canals, streams, and also these nodules are tanks, small tanks. It spreads here everywhere so that we don't want to get any kind of risk of flooding or no drought. Okay. You may know about tank cascade systems, so clusters of tanks because of our landscape in the dry zone. Not all places in the dry zone, but in some, like Anuradhapura district. So our landscape, this is low elevation, not the upper, but and same time, moderate undulation. This particular one supports to form clusters of tanks. And also, if you look at rainfall, you know it is bimodality rainfall. And if we just make a line, 1,500 millimeter per year, we call silver line, it has the highest density of tanks. Either side of that will have less than this particular level. And soil and geology, especially we have regolith aquifers. We don't get much groundwater here. Low infiltration and reddish brown earth and low humic clay soils in most of the cases. Okay. Just observe what is happening here, water flow. There are small tanks. There are different types of tanks. And also, there are different purposes there. So it will collect water from the upper part of this and it will go along this one, feed in these areas, paddy areas, and it will go here and it will be stored here, and excess of that will go to streams or it will go to another big reservoirs. So this is tank cascade system. We have different types of tank cascade. Sometimes tanks are there in the forest. We call kulwev. Then there are tanks without village. That is Olagamba. There are some isolated villages here and there. And there is a big canal here, right? It's like taproot of the tree, right? It will go like this. And you get paddy fields here and there. Then there are some storage tanks. Sometimes we call Yellow, sometimes we call Bisovel. And close to this major tank, village tank, there are sediment trapping measures. Well, very small tank. It doesn't have any kind of irrigation facilities, but it will trap this debris and release some sort of pure water. And here also you get another one we call Godavala, upstream water hole, to trap sediment. So that every attempt, they had this one to make crystal clear water, and people have used this water resource for drinking. Up to last 1960s, they have used for drinking. Now they can't use it because of some other problems. You know the problems, especially chemicals. Now this is 1:50,000 map, and you will see these are tanks. You can see tanks, tank ones. And alternatively, you can see paddy fields. Paddy fields, tank, paddy fields, here tank, paddy fields, and big tank, paddy fields, like that. If you look at this water flow, all this water from 65 tanks will reach here the big tank, right? That is Kalanchi tank, right? This is in Rambayava DS division. If you just draw this, what is happening here, this is the water flow. It's coming to this one. That's a cluster of tanks here. And there's another one here. This also coming to the same tank. It's a cluster of tanks. And here, there's another one. It will come to the same tank. So there are three clusters. If you just draw the boundary of these, you will find here like this. So you can understand easily what it means. These are called tank cascade systems. Okay. I just want to request, if you want to have any kind of clarification, questions, use the chat box. Then I will go through and I will explain, right? This is another one, just above Nachadu Reservoir. 1, 2, 3 tank cascade systems together. It's called tank cascade complex. 1, 2, 3. So this is Ulagalla tank cascade. This is Tirapane tank cascade. This is Mahakanavul tank cascade, because we have studied in detail for last 15, 20 years. So that we have a wealth of data, and somebody can analyze it and come up with a lot of new conclusions. And this is also another one we have studied. This is Palugassava. Horivilla tank is here. One cascade is here, like this. Some tanks. There's another cascade here. So this Palugassava tank cascade system, Bellankadura tank cascade system will go to Horivilla tank. And this is the upper part of Mallatua River basin. Okay. So there are ample of examples. We can see that in the map, or if you can just go and visit these places. So this is ancient wisdom we have. Okay. And when we try to map these as zones, This is one zone with cascade systems. This is another zone with cascade systems. This is another zone. Here you get ad hoc, but it's not a good zone. So that we have labeled these tanks. This is north and northern zone. This is northwestern zone. This is southern zone. 3 zones. Tank cascades are found in northern, north central, northwestern, Uva, and southern provinces, right? Here, as far as the provinces are concerned, like this. Then tank cascades are found in districts. Mullaitivu, here, Vavuniya, Anuradhapura, Trincomalee, Putlam, Kurunegala, Hambantota, and Montragala. Those are the districts where we get a lot of tank cascade systems. And also, if you look at this one, this elevation map, these are very plain landscape here. This is the coastal border, and this fade yellow color one, that is another topography. We don't have much here, but here that mountain part, Central Highlands, you get 3 zones. 3 zones. So 3 zones we call low country, mid country, and up country. So here you get low country, dry zone, low country, dry zone, low country here. And these are the agroecological regions. You can see clearly, especially these landscapes are there in dry zone here. And also in some cases, intermediate zone, not in the wet zone part. If you look at geology, right, we have Vani complex here. We have Highland complex here. And this is Vijayan complex. So we get this part, this cascade zone is in the Vani complex. This cascade zone is also in the Vani complex. And here also you get Vijayan complex, part of that. So that geology is somewhere is in favor of forming cascade systems. This is soil. You get reddish brown and low humic clay soils here, and red yellow podzolic and immature brown loams here. So that tank cascades are found mainly on RB and LG, reddish brown and low humic clay soils, and some on red yellow podzolic and immature brown loams. You can see that, okay? Elevation. Tank cascades are found between 800 to 2000 millimeter. Here, this is the mid-country, and the rainfall range is here 800 to 2000 range. Nothing here. And also it's not in these areas, plain areas, landscapes, less than 800 millimeter per year. So we have tank cascade systems in a lot of places in Sri Lanka, especially dry and intermediate zones. But you know that in some areas, you don't get this tank cascade systems. If you take one example, Ampara, Mahawaya, you don't get tank clusters. If you take Anuradhapura district, all districts, you will get a lot of tank cascades, more than 50 tank cascade systems. All right. So the definition came up from 1985 by Professor Madhum Bandara, our senior researcher, scholar. A cascade is a connected series of tanks organized within a microcatchment, mesocatchment of the dry zone landscape, storing, conveying, and utilizing water from an ephemeral rivulet. This is the cascade definition. So it was so enough from 1985 to up to now because it defines the water movement. When we study this one, it's not only water movement, but about our ecology, right? So that we had to come up with another definition because it defines only water movement. What about land? What about land use? What about soil properties? Flora, fauna, groundwater, human activity. So we thought that we should have another kind of ecological definitions like this. An ecosystem where water and land resources are organized within the microcatchments of the dry zone landscape, providing basic needs to human, floral and faunal communities, not only for human. Through these resources, water, soil, air, and vegetation, with human intervention. That is another important one because we cannot get rid of the factor. The people are there, but it should be on sustainable basis. That is our new definition of the tank cascade system. If you look at this landscape, right, you can see forest here, tank bed here, and some home gardens here, some isolated patches of forest like that. So here, one tank, another tank, another tank, another tank here, and it will go down to have another big tank here. So this is the cascade. If you look at this one, forget about all these land use. And here, our drainage pattern like this. It's like a branch tree. Here you can see, this is what happened. Wherever possible, especially at confluence, we have tanks. And also, one we have to think about how we can share this water for each and every tank without having any kind of unfair to one tank from the other. So these people have been settled in some places where you get more water and borrowed other water from these areas. So these are villages. Now, when you come to villages, village is a sustainable system. You get water here in the tank. It is protected by upstream water hole. And this upstream tree belt we call Gaskommana. And also some soil ridges like Issati. So whatever that come in as sediments here from Chena lands, it will be filtered or blocked by these ecological segments. Once it comes to this place, this is a reservation from tank to between tank and paddy field. It's a reservation. Kattakadua, we named as interceptor. It intercepts all polluted water coming from tank, seeping through and preventing to come here in the paddy field. Otherwise, this salt affected polluted water will destroy the paddy. And also how it can be fertilized. We have described, I think, in soil management system. Also, these segments will get some kind of waste which will be decomposed to become fertilizer source to the paddy field. So we have discussed about this early. Traditional water management practices, how it can be adapted to the climate change. They have Betma practice. Now we are getting very intensive drought due to climate change. So they have done Betma strategy. It is a practice that temporarily redistributes plots of land among shareholders, paddy landowners, in part of the command area of a tank during drought periods. This is another kind of strategy they use. Betma, that means distribution of the land lots among people, not the whole land, but the particular selected land portion. There's another one, Pangu method. That means they can sometimes see that because of the forecasting methods, they will expect that there may be high rains and there can be flood and it can be a risk to tank. So tank had to be maintained properly to avoid breach, leak and excess slippage. Repair and desiltation of tanks and cleaning of canals during dry period are shared tasks assigned to each farmer proportionately to land ownership. That is Pangu. Pangu means portion, right? So they distribute portions of these parts, segments to people who can get the things done for repairing. Kakulama, it's a dry sowing one. If you have low rainfall expected for the Maha season, farmers advance the cultivation time using early seasonal rains whenever they feel that tanks would not get enough water to cultivate the command area. How they believe this, sir? They have the experience that if September's second intermonsoonal rains are very high, the total seasonal rainfall is not adequate to fill the tank. You see that how they could be able to believe that. Now the explanation is now, in mid-September, in Singhala months, we call Binara. So they call this rainfalls, isolated rain, as Binara Kalua. So when you get higher rainfalls from Binara Kalua, Maha rainfalls are less. That is what we observe. Now there are interpretations for that because we get higher rainfalls in this Binara Kalua. This time we got this one because of El Nino effect. So wherever you get El Nino effect, you will get dry Maha season. So we will see what will happen during this Maha season. We don't expect much rainfalls. Tavulu Govitana, that is extremely dry situation. Tank bed cultivation using little rains constructing a main soil bund between deep face and shallow face of the tank bund. So they have their master bund there. Above that, they cultivate. It will collect some water from coming from the upper part due to isolated rain spells, so that they will get something. So you can see that how they could be able to face the challenges of the climate. Now this is the master bund in Tavulu Govitana to prevent. This is the master bund, right? So there are 4 strata here. One is Madakalu, dead storage here. This is Vaupiti, deep water area. Then you get another with sedges. That is called Vautaula. And finally, you will get another face here, hidden in these bushes. That is called Van Gilm. So there are 4 faces. Due to sedimentation, now we don't see these faces because the geometry is now it is uniform. Because of that, we are now facing a lot of problems like tanks go dry very rapidly and it does not meet the requirement of command area, so that they have to abandon sometime command area. Earlier, what they did, because of the geometry, they use up to this point. Up to this point, they use, excuse me. Hari අතුල මම online lecture එකක් ඉන්නේ. හරි පස්සේ කතා කරමු. හරි. Okay, right. Thanks. Here you get some water layers here up to this point. They will use for Maha cultivation if there is no adequate rainfalls during that period. And they will keep this water, all water here for Yellow season. Okay. So that is why they have practiced 2-season cultivation. One is in Maha season and the other one is Yellow season. Now we can't do it because Yellow season we don't get much rainfalls and we don't get much good storage in the tank. Okay. Earlier we had a structure we call katahoro. That means these are the kata, pieces of these pipes, put one on the other or like this. So that what they do, they will remove the first one to remove first layer of water. Second one, second layer of water. Third one, and so on. So that they will get always the surface water, which are not polluted. Now, if you look at the modern one, they will get water from the bottom, and all these poisonous part of the water mass will go to the paddy field. So you see the difference. And here you can see that when you remove this one, you will get one part of the water layer, and that is the top part. You will remove a big volume of water. Here, fairly less amount of water like that. So because of that, you can't have one single height difference for all these cattle. So they have marked this part in rocks. This is one of these. You can find it in Alistana. So here you get this kind of marks. Diyakata pahana. Pahana means pashana means rock. Diyakata means that is from this katahoro. And there's another very nice one. I can't guess how they could be able to calculate this one. This is called Karahan Kote. So after getting water from the sluice, it has to be distributed among different different paddy tracts, which are in different sizes, so that they get water from different sizes of these cuts. Here you can see. And if you look at here, you can expect different discharges, which will fulfill the requirement of water in these different paddy tracts. What they wanted to have it, they will open the sluice and allow this water to go there. And finally, once they close it, all these tracts are getting adequate amount of water for their paddy cultivation. So that is a very good one. No need to think about this now, because these are mathematical calculations. We have theories, but all these days, they don't have any kind of this principles of this BS. They didn't have. Giritale tank, the ancient sluice to which the controlling gateway under the water surface still remains lost. Here. This Giritili tank, now it's abandoned. This is Urusitara. I think better to visit these places. Now you are going to enjoy your some picnic trips to some places, but enjoy with these ancient structures. Here, Ramakanway old irrigation canal. This is the way of locking two rocks. And this is Maduro ancient sluice. And you will find here, it's a kind of miracle. Here you get some kind of openings that is loose, and you will find here empty space. They could have had it plastered in all this, but they didn't. Can you guess how? Because now this is flowing inside with the pressure. Pressure has to be dissipated because otherwise it will breach. So that these people thought that they should have some space here to dissipate this pressure. Dissipate this pressure. Right? This is in 5th century BC. And this is the origin of our Bisokotu. Right? And the same time, you get this kind of stones in these burial sites. So same era, you find the same era you find that's loose. So no one can say that before Vijay we didn't have anything. But you see, this is the same time that Vijay arrived Sri Lanka, and we had very advanced irrigation systems. This is Sibankatu. So this is again Madurai sluice, 6th century BC. Then they have developed this one, improved one, 3rd century BC. Then this is Kala Vava. So you can see the improvement of Visokotua. Right? I don't see any kind of questions in the chat box. Okay. Now I'll tell you how to operate this one, Visokotua. We have open chamber here. When water comes here, it will get the pressure, and pressure is dissipated because of this open chamber. And finally, water will move slowly without any pressure the other side of the bank. So that this is a good technology specific to our country. Our country has invented this one. Finally, Western people now, they have modified according to the same principle, and they say valve pit sluice. So we are proud of being saying that this is ours. You can see some people guessed that Visokotua had some kind of levering system to raise this gate. Okay. It's not now, it's not there because sometime it must have been made of wood. Spillways, they have their own technology. Spillways, village tank sluices, this Katahoruva must have been operated by using some more measures. This is Ridhi Bandila. There's another technique we had in the ancient time. We can have a small rock here. Small rock here. It will extend here. The flow will be divided into two. One is here, flowing here, and it goes away. So it will come back to the same area, but at a higher elevation, so that we can have gravity-fed irrigation using this particular diversion technique. Okay. Ancient rainwater harvesting technology. This is vertical flow. If you go to Sigiriya, definitely you will observe this one. This is man-made. This is another vertical flow here. And also you will come up with a very, very beautiful one, water spring. When it rains, these springs will be activated and you will get some kind of water springs. Not that much high, but some springs. How they could be able to operate this one? Just think about that. Here you can see that water springs in Sigiriya. Yeah. Think about the way that it happens. You know, for this sun, there should be a head of water to get the pressure. And once it comes here, the pressure is dissipated in form of springs. That you can understand easily. But how will they get this pressure? That's a question. Can you imagine? There are two rocks here, right? If you go to the Sigiri or Pidurangala, you will see that those are not natural shape of rocks. Natural shape of rocks. This has been modified. It's a natural rock, but modified by people. You can see some kind of activities they have done. Here it's very dominant, and you can see that how they could be able to manipulate this sun to make a flow pitch. If you go to this Vidurangala, nearby there are a lot of rock pieces, big rock pieces, which are not natural. So anyone can assume that that has come from the sun due to explosion. Who did that explosion? That's another problem. You can see this shape. All of a sudden, we can think that this must be meant for collecting water. It's a kind of funnel. And you can hear convex and concave surface areas. Yes, here you can see some lines of water to be conveyed to this area, this part. So Sigirians must have been in need of clean drinking water. That is what we assume. This is the hypothesis. So we found that there are a lot of conveying pipes, like these clay pipes, and there are open ditches, and also buried some water conveying paths. This, I could not find a picture for this one. And you can see here, water garden 1, water garden 2, water garden 3 in this area from the entrance to Sigiriya. This is water garden 3. That octagonal pond is here. That is called Atapattam Pokuna. This is a close-up. And this is at a higher elevation. It's about 8 meters higher than this sprints here. And also we did some contour mapping, and we found that Pidurangala and here the sprints, it's about difference is about how much? 200, 126. 126. But when you take this water pathway from this way, and it will come and it will be settled somewhere here with a kind of structure, and it will give you not a high pressure, but a low pressure using some clay tubes. We found this clay tubes, clay pipes here. So this is the one that we are talking about. These fountain ponds here, and this is the octagonal pond, Watapattam, so that you have enough time to get the pressurized water here. Here, the same thing you can see here. And then the problem comes how we get water for these octagonal ponds. Again, we have to draw our attention here. They must have had this plan to convey this water to that particular octagonal pond. And these rocks, you could be able to find it at the bottom of this Pidurangala. These are the natural cracks. These are perpendicular to natural cracks, that is man-made explosion. So we can conclude that this is not a natural decay, but it's a huge explosion done by people. You can see that it cannot be natural here. You have some kind of edge effect to get rid of water flowing out. And here you get some conveyance canals. So we call this one as a rainwater flow pitch. That is the rainwater harvesting techniques that they use for different rocks. And if you go to these rocks, please observe carefully. Mihintale rock, Kantirimale rock, you will come up with some sort of rainwater harvesting systems. You see, that is the ridge of the rock. You will find some kind of facilitating canals here to flow pitch, runoff ditches, and it will come down like this. It's like cascading system. These are the conveying canals. You can see. These are not natural. If it is natural, you will find this kind of shape. But these are cuts. Cascading effect for filtering water like this. So it will be good opportunity for water to get filtered. So filtering process, you can see different places. Here. Finally, you will come up with the sediment pond at the end of this Piturangala wall rock. So it will trap all these sediments coming from upper part, and it will issue water only without sediments. So it will go there, and we don't know how it will continue after this one. Yeah. If they have made a good attempt to make these all shapes, after this, they don't want to ignore this one and keep quiet. So they must have had some kind of plan to convey this water to Sigiriya, that is where the kingdom is, and we will try to calculate this one. And here we call balancing stone, right? If you take this surface, look at this one. Yeah, it's like Pidurangala rock surface. You see the same shape. You know, our people wanted to have something, a model, a mold, before they construct a big one, huge one. So that they have followed here also. This is the model. Stone mold to prepare the rainwater harvesting model. It is the mirror image of the flow pitch, right? You see, can you compare this one too? Next time when you go to Pidurangala and Sigiri, please visit all these places and think about with a free mind, and you will see that what they have done. Finally, we did a calculation with rainfall data, right? Found that annually, if you take 75% probability rainfall and 80% of runoff, it will come to this result like 10,000 cubic meters per year. And these are just from the sky, no pollution at all. So it is good for drinking. This particular kingdom, if they have how much? If they have people like this, 10,000 cubic meter of water can be collected from this system. This system, if rehabilitated, will supply annual water storage of 10,000 cubic meter to the people who are living around and are threatened with the chronic renal disease with unknown etiology. So just divide this one, say 4 or 5 liter of water for drinking per man. If you divide this one, so it is enough for them. How many people? 9,000 people can easily be sold. That is the kingdom. That is the people living in the kingdom. And also you can see when it rains, you will see these flows in this ruin structure. And also I just want to tell you, if I have time, this Stargate. Have you heard about this Stargate? This is in Ranmasuyana. When you visit Dharmasena, you can see this particular note here. It's a carving. And if you look at this one, this is a diagram. So they say that when you go there and do some kind of concentration of mind, you will go to other planets. As scientists, I don't think that you believe that particular myth. But here, you get a water circle, right, around them. And here you get a nucleus, relatively smaller than that, but there's a nucleus. So what we believe first, that this particular Anuradhapura city is covered by surrounding reservoirs. And this is the palace for governance, that is the king. And this is the temple for monks. That is, we suspect that this is Abhigiri complex. This is intercedal for King's Palace. So there are some other things like this. Now this is in Yaksaksara or Purvakmaksara. They think that this is a symbol to indicate that this place is good for living and also for having gardens. So you can see that it's a kind of land use map sometimes, you know. You see, if you just compare this one, you will see this is Abhayagiri complex. This is inner city. So you have 4 here roads like this. Oh. This particular water circle is here. 1, 2, 3, 4. What is that? Moravava, Tisavava, Basavakpulam, Bulangpulam. So according to the map, they have constructed all this. And from one king to the other, this has been transferred without change in the plan. Nowadays, what is happening that one ruler will make a policy, plan, and try to implement. Once he is getting away from this power, then the other man comes and do some other planning, policy, implementation. So these people will have to make one particular lesson from them that we should not change the plan without any kind of justification. You see how they could be able to put this water circle here, and those are facing to city. All these are facing to city. Then we thought that this is groundwater influence, right? Here, groundwater influence. In a city, you have different reservoirs. So this water culture, we have to learn more and more. Water cordon around kingdom, Tisava, Nurava, Maswakulam, Bulankulam, focus to enrich groundwater in the kingdom. Paddy lands under these tanks are relatively low, so that we cannot think that all these are meant only for paddy cultivation. Catchments are not adequate. Even though catchments are not adequate, these people have constructed these tanks, taking water from other drainage basins. What is the purpose? So tanks are fed by adjoining river basin. Alluvial soil is found due to Malatoe and Alpanoe. How these gigantic structures could be sustained? Only solution, only possible reason is that they must have trapped groundwater on the bedrock. So you can easily read this one. There are 2 types of rocks here. These rocks will show you that the water can be trapped as groundwater and make a pressure on the top, so that all huge stupa can be stood up with this pressure. Why I say that? Because these are very hard granite and chanokite. And they must have had some kind of measures to monitor water levels. You can see everywhere you will find, right? And we found that cities in the world, around the world, cities are collapsed now. The reason they found that because of depletion of groundwater. That's a very, very risky thing that we also may face. You see, our stupas are getting trapped now. So there's a possibility of having some kind of groundwater depletion. If you go to ponds, if you go to these places where wells are there, you can see that water level is far below. So what we thought that we have learned something about cascade systems, ancient water management planning, and also we thought that to go for rainwater harvesting, some kind of concepts. And finally, what we want to tell that again and again, these water resources management are not meant only for irrigation. As we discussed, human needs are there. Rainwater harvesting systems can be activated by using this water resource. Environment can be survived. City planning, Anuradhapura and Sigiri. Then parks, landscaping. And also we discuss about administrative boundaries. And finally, we want to tell that because of the climate change, we may get very intense disasters, natural disasters like flood and drought and cyclones. So that we can learn from their water resources management practices, techniques, and principles. So that it will be a good gift to the world if we can study this one in detail as scientists.